right, we've been looking at systems of equations, and before we start looking at systems of linear inequalities, I want to review just a little bit about linear inequalities. All right, so linear inequality, it's similar to an equation, but it uses an inequality symbol. All right, so if you remember your inequality symbols, you've got less than, we've got greater than, less than or equal to, greater than or equal to. So if you're on a number line, these would be open circles because the point is not included in the answer. For these is less than or equal to, okay, that or equal to means the circle is included or the point on the graph is included. All right, so we're looking at a graph instead of a number line, so that means these open circles would now be dashed lines, and the closed circles will be solid lines. So just kind of make a note. Sometimes people get confused with the inequalities. Make sure you know which direction is less than. Less than has the smaller side to the left, and greater than has the bigger side, or it opens up to the left. So that's kind of the way I've always thought about remembering those. All right, so linear inequality, similar to an equation, just a different sign, and remember when you multiply or divide, you have to change the negative when you're solving an equation. All right, for a solution of a linear inequality, it's all ordered pairs that make the inequality true. So we're going to check some of these just to see what that looks like. All right, so to determine if an inequality or to determine if an ordered pair is a solution, we have to take the ordered pair and plug it into the inequality. So we're going to have 2 times, this is our x and our y, so 2 times 2 minus 3 times 5, and we want to know, is that less than 15? Okay, so if this is a true statement, then the ordered pair is a solution. If this is not a true statement, then it's not a solution to the inequality. All right, so let's see. 2 times 2 is 4 minus 15. And we want to know if that's less than 15. So 4 minus 15 is negative 11. Negative number is going to be less than a positive number always. So this is yes. So that means 2, 5 is a solution to this inequality. That means if we graph this, this point would fall in the shaded region. And we'll see what that looks like here in a little bit. All right, let's look at another one. All right, negative 1 and negative 7, so we're just going to plug that in. So I'm going to have 2 times negative 1 minus 3 times negative 7, and I'm wanting to know, is that less than 15? All right, negative 1 times 2 is negative 2. This becomes plus 21, and when I add 21 and negative 2, I get 19. 19 is not less than 15, so this one is no. So this is not a solution to this inequality. All right. All right, we're going to check the point 3, negative 4, so we're going to have 2. Let me change the color here. Let's see. So we don't get it mixed up, so let's change to blue. So we're going to have 2 times 3 minus 3 times negative 4. And is that less than 15? So we're going to have 6. Negative times a negative is a positive 12. And 6 and 12 make 18. 18 is not less than 15. So this one is no. That is not a solution to that inequality. All right, let's look at one more. 0, 0. So we've got 2 times 0 minus 3 times 0. And we want to know if that's less than 15. So 0 and 0 minus 0, is that less than 15? 0 minus 0 is just 0. 0 is less than 15. So yes, That one works. That one is a solution. So again, if we solved for y and we graphed this on a number line, this point and this point would fall in the shaded region and be solutions of that inequality. Right, so graphing an inequality is a way to show all of the solutions or all of the ordered pairs that are solutions to an inequality. So the first thing you have to do is put the inequality in slope-intercept form. If you don't remember, that's y equals mx plus b. That's something that you're going to need to know forever, so just kind of commit that to memory. Be sure to flip the inequality symbol. So if you have an inequality, make sure if you multiply or divide, you have to flip the inequality. That's the only difference in an inequality and solving for an equation. All right, so if you're going to graph the line, you're going to use a solid line for anything that's less than or equal to, or greater than or equal to. And you're going to use a dotted line for the less than or greater than. That's kind of what I showed you on the chart here a little bit ago. All right, so you're going to shade above the line when it's greater than or equal to. And this depends on the slope. So above the line is important because if the slope is going down, the shaded area will be on one side, and if the line is going up, the shaded region will be on the other side. So make sure you always know greater than, and greater than or equal to is above the line, no matter what the slope is of the line. All right, you're going to shade below the line for everything that is less than or equal to. All right, so we're going to look at a few examples. All right, so an example, 2x minus 3y is less than 15. So the first thing we need to do is solve this just like it's an equation. So remember, you can use a little line if you want to, because when you move across the inequality symbol, it's kind of like moving across the equal sign. You've got to do the same thing on both sides. So since I'm trying to solve for y, because we're trying to put it in slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. So the first thing we want to do is subtract 2x from both sides. All right, again, I do the same thing on both sides. So I'm going to bring down my negative 3y. I bring down my less than symbol. And I'm going to rearrange this because I like to have my slope in front, and my slope's always attached to the x. So I'm going to have negative 2x. And since this doesn't have a sign, that means it's positive automatically, so plus 15. All right, now I'm going to divide by negative 3. Now when you divide by negative 3, you divide everything by negative 3. And remember, you have to flip the symbol. Okay, so flip the symbol because I divided by a negative. So negative 3 divided by negative 3 is positive y. And then I've got a negative, and a negative is 2/3. X, that becomes positive because 2 negatives is positive. And then 15 divided by negative 3 is negative 5. All right, so to graph this, I'm going to start by using my y-intercept. It's always on the y-axis. So this is my y-axis going up and down. It's my vertical axis. So I'll go down 1, 2, 3, 4, 5. So that puts the y-intercept, that puts my b, that puts this number on the graph. And then I'm going to use my rise over run, or my slope, to graph another point. So from the point I put on the graph, I'm going to rise 2 and run 3. Rise 2 and run 3. And it's kind of going to put me off the graph here. And then I'm going to decide, is it solid or dotted? Okay, remember less than and greater than are dotted because there's no line under it. That means the points on the line are not included in the graph. So I'm simply going to make a dashed line. I'm going to put arrows because I know that line continues. And now I have to say this is y greater than. Greater than means I shade above the line. So it's going to be everything above the line. So you can take a pencil, shade all of this in, and that would be your solution. So what you can do is pick any point on this side, and when you pick a point, it should make this inequality true. So 0, 0 is a quick, easy point to plug in, and that's in my shaded region. So let's check very quickly to make sure that we graphed and shaded this correctly. So I'm going to change over to red here. So we're going to do 2 times. And again, I just picked a point in the shaded region. You can choose any point in this region to check to see if you shaded the right side. So I'm going to pick 0, 0. So I'm going to plug 0 in for x and 0 in for y. So 2 times 0 minus 3 times 0. And then I want to know, is that less than 15? 0 minus 0 is 0. 0 is less than 15. This point is a solution. That means that point is in the shaded region. And therefore, I can decide that, yes, I did graph this correctly.